My name is Pat Wright. I met some of you this morning, and I am going to introduce John Thor Cornelius. And aside from being our conference chair, he has many other roles here, and I'm going to read you some. He is medical doctor and psychoanalyst who has worked in medical settings throughout his career, including as hospital psychiatrist, the medical director of an intensive mental health program, as an educator, and in private practice. He studies the integration of scientific, philosophic, and psychological phenomena, and he's surviving his children's adolescence so far.
Pat, thank you so much for the introduction. I have a challenge here. I sort of, as one of the people planning this conference, I was like, okay, I should put something out here. This is actually a part of a longer talk that I've given a few times with just taking out the genetic component, because I think this is a piece that sort of reveals something, not just about genetics, but I think about all of science and how people even think about science. So I think it has some real value. But let me just say this, because when we're talking about questioning genetics, I think there's really a broader issue that we need to be thinking about, which is understanding science and understanding what makes science work well and what science is at its worst and what science needs from us to be better than what it is right now. Okay? So when you look at sort of classic models of science, the way it's played out now, I'm proposing, is it sort of looks like this. The population is on its knees. The scientist is the all-knowing one who has the answer, who just delivers the answer to people and just tells them the truth. They're the all-knowing God who sort of tells you how it is, and we're just supposed to take it in. The problem with that is these things get problematic. As in, they're not even good for the scientist. As in, anyone who starts to be thinking that they're a god, they start to act like it, and they have all the problems of that. And there's sort of this collapse in the capacity to think, as in the scientists themselves can't think through their own science completely well enough to be able to get at anything that's even approaching reality or truth. So the other position that we can take is where we just sort of stomp on science and we just say, well, I don't care what science says. Science is proven to be corrupt. I don't care what it says. I'm going to say what the truth is myself. And you see that happening today where people are just like, well, I just totally reject science. I'm going to just say what the truth is, and the truth is whatever I want it to be. And I don't think that works either. What we need instead, I think, is what this conference is all about, which is how do we actually have a real dialogue where we actually get at things like knowledge? And Wilfred Bion, who I always really like, he talks about knowledge and he says, like, one of the ways you can know you're getting close to knowledge is that you're in agony. And I actually think there's a lot of truth in that, because I actually think as we get closer to something real, it hurts because it challenges us. It makes us think differently. And you can almost tell when we're getting farther away from real knowledge because things seem really easy. So let's use this genetics, the concept of genetics, to sort of explore this and how it got easy, how we can be challenged, and how we can sort of make our way through this maybe in a way that can get to something better. So dialogue begins with understanding, and I'm going to try to give a little bit of understanding here so we can sort of get to the root of the issue here. So when we're looking at the organic argument for psychosis, so the organic model that they have, they basically, most of the time, generate the argument this way. So there's this mechanical model of the mind. It works like a machine. They have all these case studies to sort of prove their points, say, look at this person, look at this person, look at this person, look at this person. Therefore, we can say our conclusions are correct, that the mind works like a machine. We can look at brain structural changes, so we can put people in MRI machines and we can do all this stuff and we can show these changes, so that proves that people are machines. You can look at genetics, which is the point of this talk. And therefore, if you look at genetics, if genetics are proving something, then we must be machines. And if you look at neurotransmitters, wow, we have neurotransmitters, therefore we must be machines. Okay, so they use these different arguments. Now, I'm really just focusing on the genetics today. We'll talk very briefly about the others. But when people talk about genetics, they mostly are talking about two different areas. They're talking about heredity and they're talking about genes. So when we're talking about heredity, we're really talking about twin studies is basically the evidence that they've had, which is they have all this data collected from a whole bunch of twins. And they basically look at, well, if one twin had X happen, what's happening to the other twin? And they sometimes even have twins that are separated at birth. And then they say, wow, if they're separated at birth, it must not be social, it must be genetic, it must be mechanical, what's going on. And so you see studies like this from Biologic Psychiatry in 2018 that use the Danish twin registry to estimate the heritability of schizophrenia to be 79%. Okay, so just to let you know, 79% is an incredibly high number. Like, that is like stunningly high number. Like 79% is like, wow, that's really convincing, you know. And Hilker and et al., all these people did this study. It's a big number. Okay. So the next one that they point to is genes, and they actually look at the genes themselves to find associations. Okay, and there are literally thousands and thousands of studies that have been done now that propose various genes associated with schizophrenia and associated with a lot of other psychological disturbances. For example, there's just one study in 2016 that just by itself found 504 proteins associated genetically with schizophrenia. And these studies have come out, and there's so many of them that now, even in the beginning of scientific articles, they will just say, it's been proven that schizophrenia is genetic. They'll just say that in the beginning without citing any sources because they just assume that this is true. Now, this is pretty convincing stuff, right? Like, if you just, you know, if they're on high and they're just sort of telling us how it is, we're sort of got this problem. And the question is the case closed? You know, are we in this position? But I'll put forward that again puts us in this sort of disabled position, and I actually don't even think helps the scientists themselves who are sort of proposing this argument. And maybe we could help them out. And I'll put forward maybe even scientists could help us out. So let's look at these arguments a little bit more closely and actually try to have a real discussion about it. So to do that, we need to understand a little bit about genetics. And the first thing we need to understand is that there really are unequivocal genetic disorders in my mind. And Huntington's disease is a good one. And once we can understand what an unequivocal genetic disorder looks like, then we can start to ask more questions. So for Huntington's disease, there is an actual and predictive heredity. In this case, it's autosomal dominant, which means that if one of the parents has Huntington's disease, each of the children have a 50% chance of having Huntington's disease. And you can just follow this through the generations and you can just see it happening. Bam, 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 bam. Okay. And, you know, if we study Mendel, you can see why and you can understand, but it's a very obvious process. The next thing is when you look at the genes themselves, you see an identified chromosomal abnormality. So for in this case, on chromosome 4, in this one little section, you can see these CAG repeats. Okay, if you have a certain number, you're fine. That's normal. Okay, you do not have Huntington's disease. If you have more than 36 of these, your body actually starts to produce a protein that is abnormally long. Okay, and it says right there, 36 or more glutamines. And so you basically have this protein that is too long, and you can actually see it starting to mess with the machinery in the cell, and you can see it basically making the cell not work very well. And then you really see this direct line of this causing this, causing this, causing this, causing this. And so this is sort of, in my mind, sort of an unequivocal genetic disorder. And I think most doctors and scientists sort of see this as, okay, yeah, I can, that makes a case for genetics for Huntington's disease. The question is, how about everything else? So if we look at this paper from Biologic Psychiatry, the heritability of schizophrenia to be 79%, what does that mean? What happens if we drill down? So the first thing that we should know is that nobody, and this study included, they found that they couldn't find it to be autosomal dominant or autosomal recessive. It was something else, okay? So we don't have that solid piece of evidence that would tell us, okay, it's following this sort of specific pattern. But then we have to say, like, well, wait a second here. What is going on? How did they come up with this 79% number? And has anyone actually even thought about this? And fortunately for us, someone has. These two guys, Colin and Andrew Ross, actually wrote an editorial in response to this article, and they actually looked at the numbers. Okay, so what they found is autosomal dominant, no, autosomal recessive, no. And then they asked, well, wait a second, did these guys even use a standard textbook method of figuring out heredity? Did they actually just use the textbook? And the answer is no, these guys didn't even use the textbook. And so then the question is well, what did they actually do? So they actually looked. And what they found is that these guys actually did a whole bunch of statistical maneuvers. And I'm not a statistician, but I'll just tell you, they did a whole bunch of statistical shenanigans, okay? They basically messed with the numbers. They added all these things. They did all these manipulations. Buried in the math, you see things that are just sort of like, well, wait a second, why'd you do that? And there's only one answer why you did this. You did this to make the numbers look better, right? And so you start to go like, wait a second here, like what is going on here in your own numbers? And they're all done to inflate probability, okay? And so these guys actually did this interesting thing is that they then started looking at all the other studies, twin studies that had been done about this same issue. And they found that the same statistical shenanigans have been used over and over and over again since 2003. And so it's pretty amazing, basically. And that, you know, this is sort of funny. And so the question is what is the textbook heritability of schizophrenia? Like if we actually wanted to, like, okay, ignore what they did. What if we just took the numbers and just plugged it into the textbook? What does the textbook come out with? And this is what the textbook came out with. The textbook came out with 23%. Okay? So it goes from a claim of 79% to a claim, an actual number of 23%. Okay, now we're going to hold on to that 23% number. We're going to find out more about it later. I'll tell you, once we start getting down into those kinds of numbers, the answer is not much. Okay, it actually is not much, but we'll grab onto that number and look at it a little later. Okay, so then we're going to talk about genes. Okay, now to talk about genes, I'm going to look at a parallel thing next to the diagnosis of schizophrenia, and we're going to look at another thing that has had a lot of similar kinds of genetic studies done, which is sexual orientation. So here's a study, or here's actually an article that was done about a study. Largest study of gay brothers homes in on the gay gene. So I don't know if you guys remember the gay gene, there's a gay gene, this is the gay gene, that's the gay gene. Similarly, in our field, it's sort of like, oh, well, this is the schizophrenia gene, that's the bipolar gene, this is founded the gene for depression. It has that same kind of feel. And, you know, here it is. The study clearly links sexual orientation in men to 2 regions on the human genome. And you'll see this again and again and again, okay? So the question here is, what do they actually mean with certain kinds of words? Like here, I'm using the words propose, associated, okay? And what does that mean when we say things are associated, proposed, clearly linked? Okay, what does that mean? Is this a Huntington's disease kind of clearly linked, or is this something else? Now, when you look more closely, it's something else. So this is how a lot of the studies in genetics are done. They're done using something called a genome-wide association plot. So what you have is you have the whole human chromosome, whole human genome right here on the bottom. And you have, if you take a population and you say like, okay, how many people are saying they're gay, or how many people have been diagnosed with heart disease, how many whatever, and you're comparing those, you'll see these little spikes along the whole process here. And the idea is that, oh, well, for example, if this spike over here is really high, that must mean that they're related, right? They must be, because they're spikes. It's a high spike right there. So that high spike must mean that one causes the other, right? And I mean, I hate to break this to people, but like scientists are not as smart as you think. Like this is literally what we're talking about. They literally like, that's a spike, therefore it's true. Therefore that gene right at that spot must cause what we're looking for. Okay? So, and then papers get written. Okay? So this is what we're talking about when we see proposed, associated, linked. Like in the fine print, you'll find out that they did a genome-wide association plot to generate these two things. And you see thousands of papers published. Thousands. It's crazy. Yeah, big pile, big pile. The problem is this is based on probability statistics. This isn't based on pathophysiology. Okay, so they're not looking at this actual chromosome and seeing what it actually does. They're just saying, well, that was a spike there, so it must be true. They must be associated, or I'm calling them associated. How they're associated, I don't know. I'm kind of messing around here, but it's just based on statistics. There's no chromosomal abnormalities that are necessary to generate these kinds of papers, and there's no genetic heredity pattern necessary either. And this is a paper that came out right when they started doing these studies from the Journal of the American Medical Association, and they're pretty upfront about it, right? The problem with the GWA approach can be problematic because of the massive number of statistical tests performed to present an unprecedented potential for false positive results. Okay? False positive results. So it's things that happen to be correlated, but they're not causal. So let me give you an example of something that's correlated but not causal. Uh-oh. Uh-oh. Let's see here if I can do that. Okay. Okay, there we go. So does correlation equal causation? So there's this really famous nutritionist actually who talks a lot about correlation and causation. And he brings up this funny story of correlation and causation. So it just so happens that the number of telephone poles in a country is correlated to the amount of heart disease in that country. Okay? So the more telephone poles you have, the more heart disease you have. Okay, so if we just assumed that correlation equaled causation, we actually have the cure to heart disease. The cure to heart disease then would be to cut down all the telephone poles. Because if we cut down all the telephone poles, we would cure heart disease, right? No, I think we know this is not true at all. These are things that just happen to be correlated that aren't causal at all, okay? And just like this example shows, it's the same thing is true in these studies. So just because there happens to be a spike right there, it doesn't have anything, it doesn't prove at all that one is causing the other. Yet all these studies come out again and again, and they don't prove the causal part, they prove that that spike actually just happened, okay? Which is very different than proving causation. So correlation does not equal causation, okay? But as you can imagine, this is actually very easy to do, which is why there's tons and tons and tons and tons of studies about those. Actually trying to find a gene and see what the gene is actually doing that's producing a protein, blah, blah, that's hard. That's really, really hard. And so there's practically no studies that actually try to do that. Very, very few. So let's look at this. So no evidence of causality provided, causality is explored. But let's go and look at other scientists who have maybe tried. Like there's scientists who are trying to do these things, trying to look deeper, or at least wondering about these studies that keep coming out, these genome-wide association studies. So for example, in 2019, this was a big study published in Science. They noticed the literature on genetics of being gay was whatever, it was based on genome-wide association studies. Okay, so that they tried to do is they tried to get enough data that they could actually really examine this issue. And what they did is they looked at 500,000 individuals and re-examined the data. So this is actual big numbers, okay? So they're actually really, really looking at these numbers. And at best they said, okay, at best we can say maybe associated, there's really only 5, and it's associated with sexuality, not even orientation. They couldn't find any chromosomal abnormalities whatsoever. It was not predictive. There was no genetic heredity pattern that was found. And again, they only found that 25% number again. Okay? And what did they do with this 25% number? They basically published the study, and the study came out, and this is the cover of Nature that just says, no, there's none. Okay? So if any, this idea is still floating around a little bit, like, is there a gay gene? The answer is no, there is no gay gene, okay? There might even be more studies that come out and say like, oh, well, this was associated, that's associated. The answer is until you have something like the Huntington's study that I was sort of showing you, this Huntington's disease kind of formulation, you do not have a connection. And science right now is pretty unanimous about this, like there's no gay gene. Okay, so, sorry, there's a genome-wide association. It's a little poopy. So let me just jump a little farther here. So this is an article that even came out before the Nature one. In 2017, Biological Psychiatry. So this is published in Biological Psychiatry, doing the same thing with psychosis. And I'll just read the title here. So, no evidence that schizophrenia candidate genes are more associated with schizophrenia than non-candidate genes. So that's a little bit of a complicated statement, but it's the same thing. Basically, there were no current schizophrenia candidate genes that have been found to be causative in schizophrenia. Okay? Most are no more associated with schizophrenia than would be expected by chance. Okay? So again, by sort of looking deeper, we sort of have an idea here. So if anyone ever tells you like, oh, well, you know, there's a gene that's been causal in psychosis, how many are there? The answer is 0. There's none. Okay? And instead we're looking at a process that's actually happening within science about people trying to have a debate, and how do you actually have an effective debate? You know, where somebody will come up with one of these genome-wide association plots, and they'll be like sort of doing what anyone does. Like if I wrote a paper that had some association, I'd want it published. I want it, you know, to be on the news. I'd want it all these things. And so you sort of promote things certain ways, but without a more full discussion, we can't get to deeper issues. We can't get to ideas about like, well, what is actually going on here? And in this paper, it's sort of interesting because they go so far as to say that this should serve as a cautionary tale for all genetic researchers in an attempt to prevent future inappropriate claims of genetic association. So, you know, rather than there being sort of the truth being delivered from on high, you know, again, we're really seeing like there actually needs to be a lively debate. There needs to be an actual discussion going on here, trying to get at ideas that might be true, more true, however we want to think about it, instead of this sort of model that we have now. Okay, enough of that. So I hope I've been able to talk here about when we're just looking at the genetics and the heredity and the genes, I hope I've been able to show that there's real problems here. You know, there's actually real problems with how this argument gets formed again and again and again, and it gets presented as like, well, obviously. instead of being like, well, really? Is that really what's happening here? And again, this is out of the scope of my talk, but I will go on to say, every single argument that can be made for the organic argument of psychosis actually has very reasonable counters to it. So for example, just like one side could come up with case studies that seem to support their hypothesis that this is an organic illness or something like that, there are as many case studies that indicate that it's not. There are many case studies that go way back there that seem to indicate the opposite. Okay, and when they talk about brain structural changes that they do a lot, which is sort of seems convincing because you can throw up an MRI, modern concepts of neuroplasticity really clearly show that this doesn't mean it's organic. It's neuroplasticity right now really indicates that the brain is much like a muscle, which is if you're using something, it gets bigger. If you don't use it, it shrinks. So for example, there has been a significant number of studies that have shown that people who are struggling with psychosis acutely, their hippocampi tend to shrink. Okay, and this has been shown enough times. Okay, however, that doesn't prove that it's genetic, like that it'd be preordained that these people's hippocampi shrink. It's not. So for example, they actually had a study where they actually looked at people who had recovered and they noticed that their hippocampi grew right back to its previous size. Similarly, they've found that people's hippocampi shrink if they have sleep deprivation. Sleep deprivation isn't genetic. Why are we calling this other process genetic when it's sort of responding in a very similar way? And so once you sort of understand neuroscience a little bit more, you can actually have a more in-depth discussion about this and sort of toss aside some pretty superficial arguments. And I'll just talk about neurotransmitters. I think anyone who studied a lot of neurotransmitters, basically the theory of the chemical imbalance has basically been discredited. And most people who study the science now realize that. Now it's basically the role of commercials, or people who haven't studied the issue or looked at a variety of studies that actually show that it's actually much more complicated than it gets presented. So taken as a whole, every piece of the argument has a counter. And this is my big statement. Really the evidence that psychological forms of mental distress have an organic etiology continues to be actually a scientific dubious claim. Nobody can prove it. They can't. People have tried. Like when studying the genome first came out, people were really hoping that everything would be found to be genetic. And while there have been specific cases where that's been proven true, the overwhelming evidence now shows that most disease processes might have a little tiny bit of genetics on the side, but that most of it is something else. And so now I really do think, I might be biased here, that there's actually much more evidence and consensus that these experiences are primarily related to psychological adversity in the context of psychological resilience, and that we're really looking at an adversity on one hand, resilience on the other. And once we start seeing that, we start realizing that it ties in with what we sort of knew all along. Like, for example, in the last talk that was in this room, forgot his name, but he was sort of talking about how in the Pacific Northwest and the Indians from his culture, if you ask the elders for a long time what was causing an imbalance that would present this way, and they would say it's trauma. And yes, guess what? We've come a long ways from there, but the answer is really still the same, and it's proving to be the same. So hopefully what I'm hoping to convey in this talk is that I think our job is to sort of figure out how to have a stance where we're not either idealizing science or rejecting it, but also figuring out how to embrace it in a way that it's actually supposed to work, where it actually is engaged in an active and meaningful and challenging dialogue where we can actually go forward. So for example, like in my mind, during periods where science was really flourishing and in areas where science still flourishes, what you see is people who are challenging each other and really actively thinking and challenging and growing. It's not areas where there seems to be like one side that's holding the microphone and the other side doesn't get to have it at all. And I think the question is really how do we get back to a place, and how do we have a place where we're able to do that? All right, I think that's good. Okay, so that was my presentation. Jim, do you have I think we have a mic for you here.
Thanks for really important, excellent talk.
Oh, is it on? Check. It's almost, there you go.
Okay, I have a question. And the question is this. It's about, do you believe from your studies and as an interest in this area and as a physician, what about biological vulnerability of individuals for psychic vulnerability? What I mean is, clearly there are some individuals who are born with physical vulnerabilities, like not every child develops type 1 diabetes, but some children do. So clearly they are born with a certain biologic vulnerability to that disorder. And do you think that something like that goes on in terms of vulnerability to extreme psychological states and a vulnerability to a more than usual difficulty in processing traumatic experience?
That's a really good question, because I think it's sort of a nuanced one. So regarding genes, like we do think genes are important. I'm standing here, I might look the way I do in large part because of genes. Genes are forming our brains. It must have something to do with it. And so at some level, it has something to do with it. I think the real question is how much and to what degree, and it has to do with how you even think about how the brain works. And in that regard, I mean, do I think, in 50 or 100 years, they might find some very nuanced ways that the genome might be playing some subtle way involved in it? It might. But I actually think there's sort of emerging models that are coming out now about how the brain works that are so different from how we think about how the brain works right now that it's completely different. So for example, the model that I personally subscribe to is, rather than thinking of, right now, the main model is sort of like the brain is a whole bunch of extension cords that are all connected to each other, and where they plug into each other, that's what matters. Okay, so that's a model of how the brain works that is basically pretty much centered on the synapse of the brain, right? There's emerging models that actually show that each neuron of the billions in your brain is much more akin to a musical string, and that there's actually an oscillating wave that happens along that string. And then you really think of your brain as being a massive symphony, a symphony of like 60 billion strings. And that it's really the music that is created in that process that is basically based almost completely on information. And that information and how that information is used in the brain is really dynamic, and it's really adaptive, but it really works in a way that basically is completely different than how we think of it right now. And I think once we start thinking about those kinds of models, I guess the answer is maybe, but again, it's maybe with at least from right now, from a practical standpoint, it would be maybe in the very small degree. So.
I am very null in biology and medical studies and so on, but I heard of this guy who won the Nobel Prize for quantum physics, and he wrote his last book about the cells and the quantum mechanic for the exchange in the synapse. Huh? No, another name. I'm old, you know, I don't remember the names. And then another, I have 3 quotes. The second is the book Hidden Valley Road.
Oh, yeah. I was thinking about that.
Yes,
Oh.
and it's a family of 12 children,
Oh, I've heard of this.
among them twins, who almost all had schizophrenia, and tons of money were spent on them until the youngest did a psychotherapy and discovered that they had been abused, all of them,
Right.
by a priest, by one of the oldest boy who raped the youngest, and so on. And
Yeah.
the third quote is, I think, Michael Snyder, who is at Stanford, who is a genetic worthy, who studied his own. He made experiments on himself because he thought that instead of taking a drop of blood in a sample, he would take regularly every day on himself. So he couldn't be accused to abuse patients himself. And he discovered that there was a history in the evolution of the genes on his side. And he wrote a book, I can't remember the phrase, but which sounded with us. You know, there is a transformation. It's not a replication like that. Michael Snyder.
Michael Snyder. Yeah, I mean, that very much fits with, you know, this idea of, you know, like, how do we learn language? You know, do we learn language genetically, or did we learn language through a process that was really about something very deep that sort of passed on through the generations and passed on through experience that then affects the rest of the symphony of the mind and how it's working? And I think these other models are gaining more and more support. I actually really do like quantum mechanics and brain function. It's really interesting how much they actually overlap and how interesting it is. So it's actually this really exciting area. So.
Wow, I just want to make sure this microphone is working. Can everybody, it's working. Okay, let's be sure to hold it up really close to your mouth because I think that makes a difference. I don't know in what order. We'll go Claire and then we'll work our way over here. Okay, thanks.
My question is based upon a tiny bit of information and combining Jim's observation and question and Francoise's. I understand that people who have been born congenitally blind do not hear voices, and it's related to your suggestion that the synapses play a huge role in the potential, or play a role in the potential for the array of experiences that are associated with a diagnosis with psychosis. And Jim's question about, I'm now forgetting your question, but
is there a biological
the biologic, right.
biological vulnerabilities?
Yes. Yes, and I have also used the language of vulnerability and Francoise's work in terms of trauma and the different kinds of trauma born of war and refugee flight, and, you know, of course, racism, and the fact that for those who for people who are highly sensitive and observant and see everything, see the expressions, feel the energies, and process all of that within their bodies, within their minds, probably minds first and then bodies. But the degree to which that those experiences, those perceptions, those traumas of a sort, because they're things that go beyond beyond understanding, beyond language, and the ways in which those play out, that given an array of conditions might result in those experiences.
Absolutely.
I don't know if you had a comment to that.
No, I definitely think that we can understand that things are multifactorial, but I actually think they combine in a way that on one hand, we can know some things like, I think everyone knows that like adversity equals difficulty and stress on a mind, and psychosis and adversity, there is a connection, you know? But I also think it opens up, once we start thinking about the nuance here, that it really opens us up to things that are sort of like mysterious, you know, like it's hard to keep track of all of these nuances that we're talking about. Like I very much believe in the transgenerational transmission of trauma. And I very much believe that, you know, if my grandparents went through something horrific, that their horror will be translated to me, for example, even though I never met my grandfather, but that his, let's say, participation in World War I could be transmitted to me, and that I would be feeling it, even though I didn't know him directly. I was never at World War I. I don't know much about it, but that I would have some of that trauma inside of me, just like I carry aspects of his language with me, you know, like some nuance of his speech, for example.
Yeah.
Thank you. First, I looked it up on my Audible. It's Hidden Valley Road by Robert Kolker, Kolker, and it's actually really nice to listen to on Audible if you listen to that. It's a good reader, and it does weave a lot of science in with a true story. It's really well done. And I just wanted to say I had a different take than Francoise. Is that right? Yeah, because my take was like that the family story was not so unusual or different than, you know, one child, you know, had been raped by one brother. There's 12 kids. I didn't see that as particularly, about 50% of them had, you know, schizophrenia is what the book talks about. And so my take was, oh, there's some genetic vulnerability for sure going on here. Anyway, it's really interesting. Highly recommend it. Also, I want to say I have twin boys. One of them's been diagnosed with schizophrenia, and the other one, it is not. And you know, takes ADHD meds and things. Like, I'm watching this thing happening and I'm like, dude, be careful, don't drink, don't, you know, I'm just trying to take out environmental factors. I'm like seeing stuff and I'm watching these changes and I feel like I'm alone watching it, kind of like no one's listening to me. I don't know. The doctors just keep prescribing because they say those meds just can bring stuff on. Like, it's not good if you have a vulnerability to take ADHD meds. And so it made me wonder with these studies too, like, are there people not diagnosed who, you know, who don't get called as having psychosis, but who may have something, but it's not, you know, maybe hidden there, or maybe like about to come out, or maybe not. Anyway.
I mean, I think that's getting at a lot of the questions. I mean, the broader questions too.
And I think there's that environmental with, I don't know, I just think there's some genetic vulnerability and environmental stuff and perfect storms happening with, you know.
Yeah, I mean, it's one of those things. I mean, like on one hand, I actually think before I started doing any looking into this, you know, you can see me, I'm like a researchy sort of believe in sciencey kind of person, and I very much believed a certain kind of story. And it actually took a long time for that to get chipped away at, for me to actually start asking bigger questions and start to realize that on top of science, there's sort of stories. Like one side really, everyone wants to have the answer, which I think actually gets to our beginning talk. And so everyone's desire to have the answer, they spin their story together in a way that feels good, right? And, you know, there's this wonderful story about genetics, you know, that, you know, it's gonna, everything that happens is sort of preordained, and we're sort of, it sort of just plays out. And it's a nice story. But I think I'm hoping to show here that the truth is much more complicated. It's much more painful. You know, I noticed that when, you know, when they redid the heredity numbers, you notice the number wasn't 0, right? So it's not nothing, but it's almost like these other studies, like, well, okay, when it's not nothing, then we have to ask questions like, given now understanding humans as flawed as we are, how should we be treating it? You know, how should we be thinking about genetics? Because right now we could say, well, maybe there's some genetic component somewhere, but the thought that something is genetic is also dangerous. So for example, I had someone who I was working with who was struggling with psychosis before I saw them. They went into an ER, they were struggling with psychosis because a lot of stressors that they had been under. And in 5 minutes, they were told that they had a permanent genetic disorder that would cause, and they would have to take schizophrenia medicines for the rest of their lives. And that's after 5 minutes, right? And that is an example of this story that's run amok, right? Instead of being thoughtful, you just see one thing, you say genetics is forever and permanent and equals drugs, and that's what must happen. And I actually think that's the danger of these kinds of stories. And what we really need to do is sort of work on having a dialogue where we are all somewhat uncomfortable. You know, sort of like what we're talking about, like you're bringing up good points. Like, I can't say that it's not genetic at all, right? Like, or that there's no role. It's more like, how would we have the conversation in a way that gets us to someplace meaningful, and that fits the reality of the world that we're seeing.
Yeah, we're coming. You got a lot to go. We'll come here, and then I know you want.
My question is about epigenetics. I'm hearing it more and more about that. That seems to be a bandwagon that a lot of people are getting onto. And so my understanding of them to begin with is pretty limited, but if you could talk a little bit about that and how does that play into your conversation about genetics at large?
So I'm not an expert on epigenetics. And so if anyone is, feel free. So epigenetics is basically that, you know, rather than the genome directly causing something like you see Huntington's disease, which is a good example of something that's not really epigenetic. Epigenetic means there's all these other factors that then affect your genome, that then affect protein synthesis, that then cause changes. It's really pretty interesting. I'm going to say something that a lot of my people who study genetics friends hate, but you know, there was sort of Darwin and Lamarck. I don't know if you guys know, there was this big conversation, and Darwin was all like, you know, it's this hardware, this genome that's in the cells, and that's why this animal looks this way. And Lamarck had this idea, to not be completely fair to him, it's sort of like, well, you know, it's the animal needing something, like the giraffe is trying to reach up high, and then it's act of trying to reach up high that causes its neck to get longer, which I don't think anyone actually thinks that now. But epigenetics is sort of that, right? It's sort of like, well, you know what? If you were starving as a kid, or even if your parents were starving as kids, your body makes genes differently than somebody else's parents who weren't starving as kids. And that there is this way that your genetics follows a pattern of experience that you might have had generations before, and it's sort of following through the family. But again, that doesn't follow the hardware analogy. It's actually this experiential analogy, which is sort of mixing with the genetic story. And so it's really this sort of interesting mix. Did that answer your question about epigenetics? I mean,
Yeah, I think so. It's just this. So when they're saying, "Oh, it's epigenetics that's playing this big factor, or could be playing this big factor," that seems to be the new thing on the horizon.
yeah.
Does that go along with the genetic studies where you're saying, "Oh, it's so easy to just say, oh, there's correlation," or does epigenetics not fall into that where it's so easy to put a little bow on it and make it look like that's the answer?
Well, I mean, I think you could say it's the answer, but I think then the question is so what? So like, let's say, in the last 2 generations, the entire world went through 2 world wars that were horrifically traumatizing to pretty much almost everyone, right? So from an epigenetic standpoint, we are all loaded toward being more psychotic, as in this was a problem for all humanity. And we could say like, yeah, maybe in another time, if there were 10 generations of peace and getting along, that they would be much more resilient to stressors than we are. You could make an epigenetic argument like that. Again, I think part of the problem is part of it is making the argument, but then I also think we have to think about the ramifications of the argument. Like I'd hate for some doctor in an ER to say like, well, your epigenetics clearly show that you have schizophrenia, so I'm going to give you this drug forever. I think that's like an improper use of the argument versus like us having some idea of like, yeah, we've all been really traumatized. It's probably affecting us on a genetic level, as in literally the proteins that we are producing are probably affected by the fact that, we had massive stress or that we're living in a massively stressful world and it's affecting us on that level. I think that part's true. So. Thanks.
It's just so interesting. Everybody wants to
That's good, I guess.
have a point. Yes, it is. It's
More
good time.
questions,
You allowed
better.
lots of time for questions.
So I have a couple comments and a question, and then maybe we'll take one from the chat and then keep going. So, yeah, thank you so much for the talk. I think when we discovered, we want easy answers, and when we discovered that a codon, meaning 3 base pairs, leads to the transcribing of an amino acid, which then amino acids, in a chain lead to proteins. It's very exciting, and that was called the central dogma of biology, right? And illnesses like Huntington's disease, like cystic fibrosis, which is autosomal recessive, like hemophilia, which is X-linked, were super exciting because you could prove that. You go from one abnormality in a gene and you end up with an abnormal protein that you can identify, and that leads to a disease. Bang, bang, bang. And some of the excitement was that, then maybe we can do gene modification eventually. If we can fix the gene, then we can change the protein, we can prevent the disease. So I think, I think that there was some well-meaning, science obviously behind this, but we also discovered that there's a ton of, to the question of epigenetics, that there's a ton of genetic material in the genome that doesn't code for anything, that doesn't code for a protein. And those genes, their job is to modify the expression of genes that actually lead to protein synthesis. And that's what epigenetics is the function of the rest of the genetic material that's modulating the expression of protein encoding genes, right? And so this nature and nurture debate, has raged for decades. How much of it is the gene and how much of it is everything else? And I agree with most people here that that the vast majority of human affliction, biological affliction or human affliction, has mixed etiology. It's not just, I think that people can have biological vulnerabilities to things. And so like in your case, if you know that schizophrenia, that there might be some genetics, it's smart to say, well, I'll take the, one offspring of the situation and maybe do some environmental, what can we do to modify the environment?
Unfortunately, when you're an adult, your mom can't force
Right.
you to not be on medication.
Right,
Mm-hmm.
right. So back to the twin studies and this nature nurture debate. And when you take twin studies, in order to show that it's 100%, that the heredity is 100% biological, you have to separate the twins, right? Because
You would
if they're in the same
theoretically have to.
environment, then you can argue, well, how much of it is upbringing, family, family conditioning, culture, all of that.
There's a daughter who shows none of that.
Yeah.
Yeah. So it's not ethical to take identical twins and separate them at birth. So in all these, I've seen the same registry data, they took like 68,000 pairs of twins, but they can't. So my question is, I have never asked this until now. How do you separate them? I mean,
You can do
where's this?
adoption studies.
But but it's all observational.
Yeah, and even then I'll put forward, like, if you're doing an adoption study, when were they adopted?
Mhm.
What is going on? What is going on with the family that they were adopted into? Like, is one family that they're adopted into able to adapt, say, to the situation or what's going on better than another family, or adapts differently? And there's like a lot of questions that don't get answered. And again, it's one thing to raise the question, it's another thing to use that in a way that could actually hurt people.
Yeah.
Also the maternal, like the womb environment that they share.
The
Absolutely.
intrauterine environment. The intrauterine environment, absolutely. That, and you can't distinguish that from the genetics, right? So, and I would think too that just the numbers of twins who actually were then adopted out must be vanishingly small to end up being able to come up and say, oh, like 79% of schizophrenia is hereditary. So anyway, so that was that was the question, was just questioning this value of the studies. And
There's so many
is
do
it
you want
okay if I ask one question?
Sure, why
from
don't we
the
do one
chat?
question and then we'll go to
So a couple people have asked about bipolar disorder. I would also love if bipolar was touched on. I understand there is now research on how it is metabolic. Any thoughts on that? Another person asked, what's the data on bipolar disorder? And I'm guessing heritability is what they're.
So I haven't done as much of a deep dive into bipolar disorder as I have of this. So I am not as confident about the data. But what I have seen is, frankly, much of the same. Like, you have these things that seem like they're a really good idea. But then when you look deeper and deeper, it's more like, well, kind of, sort of, or, well, we sort of did this, and, oh yeah, it could be that, or, gee, wouldn't it be exciting if, instead of like the kind of things that you see with Huntington's disease, that there's nothing like that for bipolar disorder. It's a lot of the same sort of like, well, we did this statistical analysis and it seems to lead to that these are associated, or this is associated with that. And it's really sketchy. I mean, basically is my concern. Like, I don't know if you've even seen, there was for a raft there was something like, we'll take a blood study from you and we'll take some blood, and from that blood, we're going to figure out which antipsychotics will work for you and which ones won't. And you're just like, how did you come up with that? Like, what did you do really to be able to say that? And no, they didn't. They just sort of did one of these sort of association studies and then just sort of started doing their hand waving. And so those are the kind of concerns I have. So sorry, I can't give a better, more definitive answer for bipolar disorder. So
Actually, my understanding is that schizophrenia and bipolar are lumped together, that they're finding the same,
oftentimes.
they're finding the same
Yeah.
genes.
Yeah. I feel like we should give, right, I think she's next. You won't give her the-
Some questions similar to you, like across all the mental health disorder, like schizophrenia, bipolar, the big one, depression, the more prevalent way, or anxiety. How much the genetic weight on those diagnoses is similar to like ADHD, depression, anxiety? Is it similar to the weight of a schizophrenia, or they're less? They're more environmental factor on that?
So my understanding of it, again, in other areas, I'm not as done a deep dive as with psychosis, is that basically for any set of experiences that we call psychological in nature, it's all the same. Like as in, you see the same kind of studies for depression. You see the same kind of studies for anxiety. You see the same kind of studies. I've some for PTSD that were saying PTSD is genetic. Not sure how they got there, but maybe, you know, like, but that you can do it with any mental health disorder, but it's more of a statistical way of sort of looking at something than actually proving that this gene is causing that.
So when we look at the literature, periodically we see there's some gene for anxiety, there's some gene for depression. It's more like a thought, or
it's more like these genome-wide association studies. Someone did a study. There was a blip on the graph, and they said, "See, that proves it. They're associated." And I guess they're associated. They just might not be causal. They could be completely unrelated.
Oh.
You know, it's sort of like I could do a genetic study right now that proves that speaking Chinese is genetic. Or I'll say, like, I'm going to prove that genetically speaking, having brown skin and speaking Chinese are related.
Well, for the language, what I know, because I'm bilingual,
Yeah.
a lot of time is the environment. When a child is born, they are applicable to speak
Right.
any language in this world. That's the environmental factor.
Right.
But the thing is, another factor, another question is, you're talking about the biochemistry part, the theory of biochemistry part. If it is not credit, then how the medication work? Well, psychiatry give a medication daily and day out, how the medication work on the symptom.
That's the question, right? And actually, when you really do a deep dive into saying, like, well, how does an antidepressant actually work? If you really, really do a deep dive into how an antidepressant works, you actually get, I don't know. That's actually how it works. And like, I love it. Like when I was doing this study, it was Wellbutrin was the thing. And, you know, like every 6 months, a different mechanism for how Wellbutrin cured depression came out. That was completely different. Oh, it's the nicotinic receptor. Oh, it's affecting this receptor. Oh no, it's changing the chemistry over here. Oh, it's doing that. And there's sort of story after story after story that sort of comes out that's based on top of other stories. You know, like these are all assuming that the chemical imbalance nature of how the brain works is the description. And I guess maybe a part of this is it's not taking into account that most of how we understand the brain is we don't understand how the brain works, you know, and it's sort of being over enthusiastic about these little tiny bits of associations that we might know, and then trying to use that to, I'm going to be unfair here, but to make money.
Oh, so clinically we see it work, then we assume it work.
Yeah. So
I think we have one more, and I think it's the end of the time, so if you do have to leave, but okay, I know you will.
Well, we'll see. So one, I wanted to say thank you. I think you are an excellent presenter. I saw you present several years ago. Such good work. Thank you, right?
Thank you.
See, I got the French Quarter backing me up here. What I noticed coming up for me is a frustration for my clients who have been, because you are very professional. I'm going to be a little less professional. I think that there is a certain amount of influence, not just people misrepresenting their statistics, purposely misrepresenting. And I think that can maybe be excused if we are looking more kind of academically. But like if I'm talking to a client who's been told basically a lie, like you said about the chemical imbalance theory, that's been disproven 15, 20 years. It's now barely filtering in, you know, to clinical work. And I think that is so frustrating. unacceptable,
Yeah.
right?
I mean, just to give you an idea about this, I did talk with somebody at Eli Lilly who wasn't on the marketing team. They were on the research side, but they were also sort of knew about the money. And basically for 5 years, Eli Lilly, this is a huge multinational company. The only reason that company was able to stay in the black was because they had a patent on Zyprexa. One drug was keeping the entire big pharma company alive.
Right.
Now, they're invested in a certain storyline. Like, you better believe it, because anyone who's not invested, like if the CIA said, or that CEO, sorry, CIA.
I didn't say it. I didn't say it.
I'm getting there. Like, look at me. But if you're the CEO and you say something like, well, I don't know if I'm a big believer in chemical imbalances, and you're the CEO of Eli Lilly, how long are you going to stay the CEO of Eli Lilly?
No.
0 days. You're immediately fired, right? So there is pressure, and there is very real pressure. And there's people who've written books who are from the industry who just talk about the kind of pressure that they're under. And, we can beat them up, but you can also sort of have empathy for them. Their jobs are all on the line.
Maybe not today so much empathy. Let's have a
Okay,
little
maybe.
more. Let's put a little push. The only other piece I do want to toss out is I think that part of what we're talking about, like your examples about epigenetics, was trauma. War is trauma. So I think so often these examples of what might be causing, we're talking about environmental impacts on a person and how they cope. And I think you can't talk your way out of Huntington's disease. You can't lifestyle change your way out of it. However, you can out of mental health. That's a big deal. Like, you can't out of diabetes 1, you can, some people, out of diabetes 2. So I think what we're talking about, what is genetic or hereditary, we really have to be more accurate. Maybe, I don't know if that's even the word, but we have to be maybe more pushy about, like, there's a lot of terms, and then we need to look at, well, but if this is something that can change, that may not be the definition of hereditary, right? And again, that's a very layman's description.
It's a
but,
really good point.
Yeah, I just think I absolutely super appreciate your presentation. I just noticed so much caring for people who have been harmed. And we sometimes use terms like, oh, that's no longer the theory. And it's like, but people's lives were changed for decades because they were told a lie, a specific lie. So sorry.